Trenching is a common enough construction job. Most people regard it as reasonably simple. Despite this, every year a number of men are killed by trenches collapsing. Those concerned did not know the dangers or simply took a chance. Supervision of trenching is important. You cannot gamble with men's lives. Conditions vary from site to site, and this short video can only show some of the practical aspects of trenching and point out the kind of things that a supervisor must check. This particular trenching job is at Oldham, where new sewers are being constructed to increase the capacity of the sewer system. The work is for the Oldham Metropolitan Borough Council, who are acting as agents for the North West Water Authority. The trench follows the line of a road, mainly of residential housing, but there are also a few commercial buildings. Traffic has been diverted and fencing put up to keep pedestrians away from open trenches. Services which cross the trench have been located before trenching starts. Their positions are marked on the road and confirmed by trial holes or careful digging as the trench is opened up. All trenches deeper than 1.2 meters, that's 4 feet, must be supported where there is any chance that the ground could cave in. It's also important to avoid damage to nearby buildings and services. Choosing a suitable method of support and installing it correctly will achieve this. The soil here is a stiff clay, but there are occasional pockets of fine sand. The engineer therefore specified that the trench faces must be supported by full sheeting. Standard trench sheets are being used. Trench sheets have the advantage that where a service crosses a trench, such as this electricity cable duct, only a small gap need be left in the sheeting. To support the sheeting, a heavy-duty proprietary whaling frame is being used rather than separate whalings and trench struts. The struts are hydraulic jacks. The distance between the jacks has been arranged to suit the pipe lengths. The lines of the trench are marked out, and the surface is cut along these lines to give a clean edge. A clean edge makes future reinstatement easier. A hydraulic pick breaks out the road surfacing and the old cobbles underneath. The cobbles are dug out and carted away for reuse. The ground is excavated to the level of the upper whaling frame, keeping the sides of the trench straight and vertical. This helps keep the trench sheets to a good line when they're installed. At the far end of the trench, an imported material is being used for backfilling. The clay is not suitable as backfill and is carted off the site. With the first stage of excavation complete, timber guides are pulled forward from the previous length of trench. These keep the trench on the right line and to the correct width. The upper whaling frame is lowered in with the hydraulic jacks closed up. The trench sheets are picked up using a proprietary hook which allows the sheets to hang vertically. The hook can be released remotely after the sheet is in place. The 4 sheets at the corners of the whaling frame are installed, the trailing pair of sheets, and then the leading pair of sheets. The sheets are kept vertical and up against the timber guides, and pushed into the ground with the bucket of the excavator as far as they will go. The whaling frame is now leveled, the hydraulic pump is connected to the jacks, and the jacks are extended until the whaling frame is held by the leading and trailing sheets. Friction cannot be relied upon. The frame is supported from the timber guides. The intermediate sheets are now installed. Keeping them close butted to avoid any loss of ground. Excavation continues to the level of the lower whaling frame, keeping the sheets well towed into the ground all the time. The clay becomes stiffer as depth increases, and pneumatic clay spades are necessary. The lower whaling frame is then moved forward from a backfilled section of trench and installed. It is supported from the upper whaling frame by 4 chains. The excavation can now be completed with some hand trimming to give a level base to the trench. A pipe length is picked up with a webbing sling. The pipe length is lowered onto a bedding of pea gravel and engaged into the pipe already laid. The backfill is a granular material conforming to Type 1 of the water industry specification. It is spread in layers. And then each layer of backfill is compacted by a vibrating plate compactor. The whaling frames are released as the backfill reaches them. The lower whaling frame is slid forward, as seen previously, and the upper whaling frame is lifted out. The sheet piles are now pulled out and stacked ready to use again. The backfill is topped up to the road level and reinstatement of the road surface will follow. Meanwhile, the trenching cycle starts again. Checking is an essential part of any construction job, but it is particularly important in trenching because of the potential dangers to those directly involved and to the general public. Before the job starts, check that the police have been advised about the work and that they know about the intended traffic diversions. As the job gets underway, check that the ground is as expected and that the trench support is being correctly installed. Each day, the trench progresses, so continue checking the ground and the trenching operations. But also check that fencing keeps up with the trenching and that reinstated areas are safe to reopen. These are only examples of the checks that must be made. If your organization has a printed checklist, use it to reduce the risk of neglecting an important detail. If not, the Syria publication called Trenching Practice includes a checklist as a guide. Summing up what has already been said, although each site is different, 3 basic points apply to any trenching job. First, suit the support system to the site. Second, get the trenching sequence right. And last, check and check again. This way, trenching can be safe, efficient, and profitable.